Hi students and friends, welcome to the channel Learn and Teach by Ayaz. This video lesson is about electrochemistry, so the topic is electrolysis. Syllabus learning outcomes are for the 2023-25 version for both CAIE 5070 and IGCSE 0620. Here are the learning outcomes for this lesson. Define electrolysis as a decomposition of an ionic compound when molten or in aqueous solution by the passage of an electric current. Identify in simple electrolytic cells the anode as a positive electrode, the cathode as the negative electrode, the electrolyte as a molten or aqueous substance that undergoes electrolysis. Describe the transfer of charge during electrolysis to include the movement of electrons in the external circuit, the loss or gain of electrons at the electrodes, the movement of ions in the electrolyte. Define electrolysis as the decomposition of an ionic compound when molten or in aqueous solution by the passage of an electric current. Let's begin with the definition of electrolysis. Electrolysis is the process in which when electric current is passed through a solution of an electrolyte, dissociation or decomposition of an electrolyte takes place, or electrolyte will break up into positive and negative ions. So the definition will be breakdown or decomposition of ionic substance using electric current. What are conductors? You must have clear concept about conductors and electrolytes before proceeding further. Remember, conductors are any solid substance that allows the passage of current or one that conducts electricity. Solid that conducts electricity. Reason is simple, and that is solid contains free or mobile electrons. It contains free or mobile electrons. You can call it delocalized electrons. Delocalized electrons. See these diagrams. These are the diagrams of metals. This is graphite in pencil. They all are good conductors of electricity. Good conductors of electricity. Because of mobile or free electrons. What are non-conductors? Answer is simple, and that is any solid that does not conduct electricity. Solid that does not conduct electricity. They are also known as insulators. Also known as insulators. Non-conductors or insulators does not have any mobile electrons. They don't have mobile or free electrons. Here we have some examples of non-conductors. These are the wood, and we have common and Himalayan salts. For woods, the reason is same, that is they don't have mobile or free electron, but for the salts, they have fixed ions. That's why they do not conduct electricity at all. Once these salts are melted, their ions become free, and then they will be able to conduct electricity also. Well, let's talk about electrolytes. What are electrolytes? Electrolytes are liquids that conduct electricity. Liquids that conduct electricity. Here it's due to the presence of free or mobile ions. It is due to the presence of free or mobile ions. You can include molten salts in this class. Beside molten salts, fruit juices, acids, alkalis, and salt solutions also act as electrolytes. Acids, alkali, they are alkali. This is alkali, calcium hydroxide, or lime water. This is acid, sulfuric acid. They also act as electrolytes. So you can easily now define non-electrolytes. They are liquids that does not conduct electricity. They don't conduct electricity. Because they don't have free ions, free or mobile ions. Here we have some examples of pure or battery water. This is pure or battery water. Pure or battery water, also known as distilled water. So we have other examples also, like you can include organic liquids. You have petrol. They don't have any free ions, so that's why they do not conduct electricity. Now I will talk about the electrical devices and circuit symbols. In electrolytic cell, the source of current is cell. It is the source of current. And you see on the right hand side, these are the two cells. Collection of cells are battery. There are positive and negative terminals in battery. Now, positive terminal is represented by a long, thin line, but the negative terminal is represented by short, fat line. This one is battery. In order to start or stop the flow of electricity, there are switches to start or stop the flow of current. You have switches at home. In the same way, we need switches here. Here are the symbols we will use during electrolysis. You must have knowledge about these because this will help you in the exam whenever they ask you to draw an electrolytic cell with correct circuit symbols. The symbol used for cell, this one is used for the lamp, this one is used for the switch. Bulbs are placed so that we can check whether the current is flowing or not. To check whether the current is flowing or not. If it is lit, then this means that the current is flowing. For instance, in these two cases, current is flowing. But in this case, no current. As it is not lit, it's not glowing. The brightness of light in the bulb also indicates whether there are maximum or minimum ions in the solution. For instance, in case of weak acids and alkalis, the brightness will be dim like this. This one is by weak acids and alkalis. But in case of strong acids and strong alkalis, we have bright light. Strong acids or alkalis. Ammeters are used to measure the amount of current flowing. It is used to measure the amount of current flowing. You will look at the symbol. Symbol A is used for ammeter. For voltmeter, the symbol V is used. This is voltmeter symbol V, and this is the voltmeter. Voltmeters are used to measure the voltage of cells and batteries. To measure the voltage of cells and batteries. Now, plates which carry electricity into the liquid are known as electrodes. Are the plates which carry current, into the liquid. So they are solids, and I've just told you in the beginning of this video that conductors are solids that conducts electricity. In your syllabus, two types of electrodes used. One is inert or inactive, another is active one. Number one, inert electrode like graphite or platinum. Number two, active electrode like copper. Inert electrodes like graphite or platinum can be used. Inert electrodes only provide free electrons, while active electrodes participate chemically during electrolysis. Metals below in the activity or reactivity series like copper, gold, they are included in active electrodes. Shallow battery is the source of electric current. Electrochemical reaction takes place here. which means chemical reaction produces current or electricity. Chemical reaction produces current. Hence, it is known as electrochemical cells. On the other hand, electricity or current decomposes the electrolyte or ionic substance in the electrolytic cell. It is here it's opposite to what's happening in electrochemical cell. That's electrical energy changes into chemical energy. Electrical energy changes into chemical energy. So you can write for electrochemical cells, chemical energy changes into electrical energy. Chemical energy changes into electrical energy. Both types of cells consist of two electrodes connected to an electrolyte and ionically conducting phase. Two electrodes are cathode and anode. The change from electronic current to ionic current and vice versa is always accompanied by oxidation reduction reactions. Both oxidation and reduction takes place here. In electrochemical cell, the reaction occurs spontaneously at the electrodes, and here the cathode is positive and anode is negative. The reaction taking place is spontaneous. What else? We have a cathode positive, anode negative. In case of electrolytic cell, the reaction is not spontaneous. Reaction is not spontaneous. That is, the reaction has to be forced by applying an external electrical current. The reaction has to be forced by applying an external electrical current. In an electrolytic cell, the cathode is negative and anode is positive. If you look at this electrolytic cell, this is the electrolytic cell. This one is cathode and this one is anode. And blue liquid represent the electrolyte. This is the electrolyte. Electrolyte can either be molten liquid or aqueous solution of ionic salt that undergoes electrolysis. Can be molten liquid or aqueous solution of ionic salt. Solution of ionic salt. So at anode, oxidation takes place. At anode, oxidation takes place. Where's the anode? This one is the anode. So you have loss of electron. Loss of electron. On the other hand, reduction takes place at cathode. Reduction takes place at cathode. Here you have gain of electrons. Gain of electron or electrons. Therefore, the reaction in simple electrolytic cell is redox. Therefore, redox takes place in an electrolytic cell. During electrolysis, electrons are conducted from the anode to the cathode through an outside electrical current which can be used. So electron flows in this way. Here we are having electrons. It's anode to cathode. This is anode. This one is cathode. This action can be reversed in an electrolytic cell. That is, charge moves in the solution in the form of ions from cathode to anode. So we have movement of ions, movement of charge in the solution in the form of ion from cathode to anode. So in this way, the whole circuit will complete. Electrochemical cells are used usually as batteries, while electrolytic cells are used for electroplating metals. So electrochemicals are used. Also, the recharging of a rechargeable battery is an electrolytic reaction. So during electrolysis, there's movement of electrons in the external circuit through conductors. Metals, there's loss and gain of electrons at anode and cathode simultaneously, and movement of ions in the electrolyte. So I will write here loss and gain of electrons, loss and gain of electrons at anode and cathode, anode and cathode simultaneously. A movement of ions in the electrolyte, movement of ions in the electrolyte. Electrochemical cells are used usually as batteries, while electrolytic cells are used for electroplating metals. Thanks for watching. Press like, give comments, and share my video. For more videos, subscribe my channel and press the bell icon.